Hey, welcome to Biochemistry, everybody. It's the Geek. Today's objectives are to understand the components of an atom, understand how to figure out how many protons, electrons, and neutrons an atom has, and to differentiate between an isotope and a regular element using the periodic table. Today's first topic is atoms. Atoms come from the Greek word atomos, which means unable to be cut. There's three parts of an atom: a proton, electron, and a neutron. And this is Democritus. He was a Greek philosopher, and he was the first one to really start thinking about the smallest piece of matter and what that might be. And the simple thing he did was take a piece of paper and he kept tearing it and tearing it and tearing it until he got the smallest piece that he could absolutely divide that piece of paper, and he figured that that was an atom because it's unable to be cut anymore. When we look at the subatomic particles, we're talking about the protons, electrons, and neutrons, which make up the atom. Protons are found in the nucleus. The electrons are found in the outer shell, and then the neutrons are found in the nucleus with the protons. When we investigate further, we could see that the charge of a proton is positive, the charge of a neutron is neutral, and the charge of the electron is negative. When we look at their size, proton and neutrons are relatively the same size, where the electrons are much, much, much smaller. Alright, hopefully you guys have your periodic table of elements in front of you. We're just going to do a little review. The first thing I want to start with is the difference between groups and periods on the periodic table. Groups go from top to bottom, or north to south, and periods go from left to right, or east to west. There are 5 different groups of elements that we want to talk about: the noble gases, the gases which are not noble, nonmetals, metals, and transition metals. Today we're just going to worry about identifying them. Later on we'll explain why they are classified as what they are. So the first group that we're going to look at is group 18. These are our noble gases. There's another gas that we need to talk about which is not noble, and that is hydrogen over in group 1. We'll go over the reasons why hydrogen is not considered a noble gas, and everything in group 18 is considered a noble gas. Our next group of elements are the nonmetals. You'll see a staircase on most periodic tables. That's going to help you identify the group that are the nonmetals. Next up we have the metals, and that's in group 1 and 2 with the exception of hydrogen. Another one that we want you to be aware of, which is actually in the middle group, but we're going to talk about it a lot as more of a property of a metal, is aluminum over here in group 13. And then everything in between group 2 and group 13, underneath the ladder in 14, 15, 16, are considered transition metals, which means that they have some metal properties and some non-metal properties. Throughout this first unit, the fundamentals of chemistry, you're going to see us referencing protons, electrons, and neutrons as pens. So we need to figure out the number of protons, electrons, and neutrons, or pens, helium has, or any element, but we're just going over helium now. We have pieces of information on the periodic table that will help us figure out the answers to how many protons, electrons, and neutrons an element has. First is the atomic number, which is always the smaller number. That will give you the number of protons and electrons. To find out how many neutrons there are, you must subtract the larger number, which is the atomic mass number, by the atomic number. So when we figure this out, protons equals 2 because that's the same as the atomic number. Electrons equal 2 because it's the same as the atomic number. and neutrons equals 4, we'll round to 4, minus 2 equals 2 neutrons. A lot of times I get asked, what is the difference between an atom and an element? An element is a pure substance that consists entirely of one atom. An atom is the smallest portion of that element that possesses all the properties of that element. So an element is a pure substance entirely of one atom. Atoms are smaller, and it's the smallest portion that makes up that element. Let's do a couple more examples of how to figure out how many pens, protons, electrons, neutrons, there are in an element. The one that we're going to look at right now is fluorine. The number of protons equals the atomic number, or the smaller number, which is 9. Same for the electrons. The atomic mass is 19 minus 9, which equals 10. Let's take a look at oxygen now. Remember that the protons and the electrons both equal the atomic number, which is 8. And the neutrons equals the atomic mass, which will be rounded up to 16, and subtracted by the atomic number, which is 8. So 16 minus 8 equals 8. Last one here, sodium. Protons, electrons both equal 11, and the number of neutrons equals 23 minus 11, which equals 12. Our last topic in this tutorial are isotopes. Isotopes are atoms of the same element that differ in the number of neutrons they have. So this means that the atomic mass will change, because that is the only way that the number of neutrons are going to change in an element. So let's take a look at hydrogen. Atomic mass 1, atomic number 1. So we have 1 proton, 1 electron, and 1 minus 1 equals 0 neutrons. When we take hydrogen that has an atomic mass of 2, such as deuterium, we're looking at an atomic number. Remember, it is the smaller number. Depending on what periodic table you look at, the atomic mass might be on top or on bottom. So just remember, the atomic number is always the smaller number. So the protons equal 1, the electrons equal 1, and now because the atomic mass was raised to 2, that means 2 minus 1, we now have 1 neutron, whereas regular hydrogen we have 0 neutrons. So this is an isotope. It's an atom that has a different number of neutrons because the atomic mass is different. So hopefully in today's tutorial we understood the components of an atom, protons, electrons, and neutrons. We've also looked at how to figure out how many protons, electrons, and neutrons an element has by looking at the atomic number and the atomic mass. And we have differentiated between an isotope and a regular element and identified that an isotope has a different number of neutrons because an increasing atomic mass. If you guys have any questions, make sure you bring them to class. Mr. Johnson and myself will be happy to answer any questions that you may have.